Good morning everyone. Myself Sonali HIVARALE. I welcome you all to our video lecture series based on the optional paper, that is the difference equation part 2, and this is our lecture number 15. Today we will see the theorem based on the EULER-Lagrange's equation and examples over it. So let's start with the theorem. So the statement of theorem is, if the simplest variational problem has a local extremum at y0 of t, then this y0 of t satisfies the Euler-Lagrange's equation. So the statement is, if the simplest variational problem has a local extremum, that is this j1 of eta, that is the simplest variational problem. If it has a local extremum at y0 of t, y0 of t या फंक्शनवर जर सिम्पलेस्ट व्हेरिएशनल प्रॉब्लमला लोकल एक्स्ट्रीमम असला, then this y0 of t will satisfy the Euler-Lagrange's equation. So this is our EL equation, that is fu of t y of t delta y of t minus 1 minus of delta of f of v f with v t y of t delta y of t minus 1 equals to 0, and that is for t in the closed interval a plus 1 and b plus 1. And since y0 belong to d, this y0 belongs to d, and y0 of a equals to a and y0 of b plus 2 equals to b. y0 belongs to d means d is the set of real valued function and y0 is the real valued function here. So आपल्याला प्रूव्ह करायचं आहे की जर का सिम्पलेस्ट व्हेरिएशनल प्रॉब्लमला लोकल एक्स्ट्रीमम असला y0 ऑफ टी वरती, देन हा y0 ऑफ टी सॅटिस्फाय करेल आपला EL इक्वेशन, जे की हे आहे. सो लेट्स स्टार्ट विथ द प्रूफ. We know that if a simplest variational problem has an extremum at y0 of t, जर simplest variational problem ला extremum असलं y0 of t वरती, या y0 of t वरती simplest variational problem ला extremum असलं, then आपण j1 of eta equals to 0 लिहू शकतो. हे आपण लास्ट थेरममध्ये पाहिलं आहे. That is summation over t from a plus 1 to b plus 1 fu t y0 of t delta y0 of t minus 1 into eta of t plus fv t y0 of t delta of y0 of t minus 1 into eta of t equals to 0. ही व्हॅल्यू आहे j1 of eta ची, that is equals to 0, and that is summation from t equals to a plus 1 to b plus 1 fu t y0 of t delta y0 of t minus 1 minus delta of fv t y0 of t delta y0 of t minus 1 and eta of t minus of fv a plus 1 y of a plus 1 y of a eta of a plus fu b plus 2 y of b plus 2 delta of y of b plus 1 fv b plus 2 y of beta plus y of b plus 2 delta of y of b plus 1 into eta of b plus 2 equals to 0. आपण लास्ट थेरम आणि लेमा पाहिला, त्यात ही व्हॅल्यू तुम्हाला मिळून जाईल. सो दिस होल व्हॅल्यू इज इक्वल्स टू 0, and since eta belongs to q was also the real valued set, and eta of a equals to 0, and that is equals to eta of b plus 2. So this both values are equals to 0, and since these are 0, we can put it over here, and since they are 0, we get summation from t equals to a plus 1 fu t y0 of t delta y0 of t minus 1 minus delta of fv t y0 of t delta of y0 of t minus 1 into eta of t is equals to 0, and that is for all the eta belongs to q. So next we will get fix S belongs to a plus 1 and b plus 1 close interval and let eta of t equals to 0. सो आपण फिक्स करू एक एस जो बिलॉंग करेल ए प्लस 1 आणि बी प्लस 1च्या क्लोज इंटरवलला अँड लेट eta of t equals to 0 for this t not equals to s where eta of s equals to 1. So this will give us f u s y0 of s delta y0 of s minus 1 minus of delta f v s y0 of s delta y0 of s eta of s equals to 0. That is आपल्या टीच्या जागी आपण s पुट केला. सो वी गेट एफ यू एस वाय झिरो ऑफ एस डेल्टा वाय झिरो ऑफ एस मायनस 1 मायनस डेल्टा एफ व्ही एस वाय झिरो ऑफ एस डेल्टा वाय झिरो ऑफ एस इक्वल्स टू 0. आपण टीच्या जागी एस पुट केला पण आपल्या एच्या जागी आणि टीच्या जागी एस पुट केला बट आपल्याकडे आहे इटा ऑफ इक्वल्स टू 0 अँड वी हॅव taken this value equal here right hand side and therefore we get this value since s is arbitrary. s ही कुठली व्हॅल्यू असू शकते जी आर्बिटरी राहील. therefore we have f u t y0 of t delta y0 of t minus 1 minus delta of f v t y0 of t delta y0 of t minus 1 equals to 0 and thus this y0 of t satisfies our EULER-Lagrange's equation and this is the EL equation we needed. So hence proved this theorem. Next we will see the example on this EULER-Lagrange's equation. So the question is find EL equation for j of y summation from t equals to 1 to 100 5 to the power t y square of t minus 6 to the power t minus 1 into delta of pi of t minus 1 whole square. So we have to find the EL equation for the given equation. Now the solution. Here a equals to 0 and b plus 2 equals to 100. So from this summation our a equals to 0 and b plus 2 equals to 100. So let's continue. So f of t u v is equals to 5 to the power t u square minus 6 to the power t minus 1 and v square. We have this as the f of t u v but we have u equals to y of t and v equals to delta y of t minus 1 square because आपण आधी पाहिलं आहे की f of t u v लिहिताना आपण काय लिहितो f u of t y of t delta y of t minus 1. सो ही आपली u ची व्हॅल्यू असते आणि ही आपली v ची व्हॅल्यू असते. सो देअरफोर आपल्याकडे आहे y स्क्वेअर ऑफ टीच्या जागी u स्क्वेअर आणि डेल्टा y ऑफ t मायनस 1च्या जागी v स्क्वेअर. सो एफ यू ऑफ टी यू व्ही इज इक्वल्स टू 2 into 5 to the power t into u and this is because we have differentiated this with respect to u. सो या टर्ममध्ये u आहे म्हणून आपण इथे डिफरन्शिएट करू शकलो अँड दिस टर्म विल बी 0 हिअर. सो हा 2 खाली येईल अँड 2 into u and 5 to the power t as it is. And next we will differentiate with v. So we get minus 2 into 6 to the power t minus 1 into v. And therefore the EL equation for the given equation will be fu minus delta f equals to 0. हे आपलं EL इक्वेशन झालं. आपण व्हॅल्यूज पुटअप केल्यानंतर एफ यूची व्हॅल्यू होती 2 into u into 5 to the power t minus delta आणि ही झाली एफ व्हीची व्हॅल्यू. सो बाय सॉल्विंग दिस विल गेट 2 into 5 to the power t यूच्या जागी y of t minus delta of this will be as it is and v च्या जागी delta y of t minus 1 equals to 0. So we have 2 in common, so we will take it common and we will shift it to the 0. Then delta of 6 to the power t minus 1 delta y of t minus 1 plus this term we have taken here and plus 5 to the power t y of t equals to 0, and this is our required EL equation. Now next example. So the question is, find the EL equation for the problem. Minimize. So we have to find the EL equation for the minimize problem, that is j of y is equals to summation from t equals to 1 to b plus 2 in the root d of t square plus delta of y of t minus 1 whole square with subject to y which is belonging to capital D. So we have to find the EL equation for the given example. Now solution. Here f of tuv is this value. So we have write it here. F of tuv equals to dt square plus delta of y of t minus 1, that is v. So in the place of delta y of t minus 1 we have written v. So this is dt square plus v square, and because this is in the root, so we have taken the 1 by 2. Now fv t of y fu of t yt delta y of t minus 1 equals to 0 because we don't have the u term, and fv t of t y of t delta y of t1 is equals to 1 by 2 dt square plus v square whole bracket 1 by 2 into 2v. So we have differentiated this with the v because you have the term with the v coefficient and we don't have the term with u. So now this will give us v by dt square plus v square to bracket 1 by 2. This 2 will cancel and v will go up in the numerator. Now thus the EL equation become delta of y of t minus 1 dt square plus delta y of t minus 1 whole square and bracket 1 by 2 equals to 0, and this is because we don't have the u term. Our equation is fu minus delta f v equals to 0. So we don't have this term, so we will go with this term only and we will shift it here, so it will give us the plus term. So now this will give us delta of y of t minus 1 dt square plus delta of y of t minus 1 whole square 1 by 2 and equals to c. So this is the constant. Now we will solve this. It will give us delta of y of t minus 1 whole square equals to c square d of t whole square plus c square delta y of t minus 1 whole square. So we have square this whole term. This whole term we have taken square of it and then we have multiplied over here. So delta y of t minus 1 whole square numerator as it is equals to c square d of t square plus c square delta y of t minus 1 whole square. C square d of t square equals to delta y of t minus 1 square into 1 minus c square. So c square and c square get common. So we will get c square d of t square plus delta of y of t minus 1 whole square. So by taking this d of t here in the left hand side and shifting this into the right hand side, we get delta y of t minus 1 whole square in the common. So take it common, and from this we will take 1, and from this we will take c square. So delta y of t minus 1 square into 1 minus c square. Now next term will be delta of y of t minus 1 whole square equals to 1 by c square upon c square. This 1 by c square and this c square. This will get into this and get into the denominator, and dt square as it is. Next, dt upon delta y of t minus 1 whole square. So we have shifted this this delta y of t minus 1 into this, and this term into this side. So we get d of t upon delta y of t minus 1 whole square equals to 1 by c square upon c square into c square upon 1 by c square equals to delta square. So that is equals to dt upon delta y of t minus 1 equals to d, and this d is a constant, where d is a constant, and that is slope of all line segments of all the polygonal must be equal to the single constant. This line segments of all polygonal must be equal to single constant, and that is the polygonal path of shortest length is a straight line as expected. That is, the polygonal path of shortest length is a straight line, and hence it is proved. So this is all for this lecture. We will study the next topics in the next video. Thank you.